Welcome to another session. In this session, we are going to talk about the theorem of contradiction. So here I start with one problem before explaining the theorem. Prove root 2 is irrational. So we are going to prove the root 2 is irrational using the theorem of contradiction method. So what is theorem of contradiction? So you can see the word contradiction, right? So here this means opposite. So we are going to assume our given number as a opposite. So in an opposite way to find out that we are going to prove that our assumption is wrong. Once we prove our assumption is wrong, then we indirectly prove that our given problem is correct or not, right? So let's start. So here they say prove root 2 is irrational. So first of all, like by the theorem of contradiction, like I said, I'm going to assume root 2 is rational number. So rational number means that format is a by b or p by q or something like that. So I take a and b. So assume root 2 is rational. So I write root 2 equals a by b. Here one important note we have to write is a and b are co-primes. So here what are co-primes? I hope you all know very well. Co-primes are the number a and b does not have any common factor. For example, it should be in the simplest form. So I write two things, 2 by 3, right? For a I assume 2, for b I assume 3. So here, so the 2 and 3 does not have any common factor except 1. So common factor is here 1 only. Okay, see, look at this 4 by 6. So here the common factor between these number is 2, right? So you can reduce this number by 2. So 2 by 3. So if if a and b are said to be co-primes, the number should be in simplest form and the common factor should in between these numbers must be 1. So it should not have any other common factor except 1. So that is what co-primes is. I hope you all know very well. So next one more conditions, b not equals 0. If b equals 0, see in the place of b, if it is 0 means that is infinity, right? So we cannot continue. If once b is 0, we cannot continue our calculation. So b must be 0. So these two conditions are very important. You should write along with this assumption, right? It's very important. So later you will find out why it's very important here. Okay, let's continue. So next step, I'm going to square on both sides. So 1 squaring root 2 whole square, a square by b square, right? So I get 2 equals, root and square will cut. So a square by b square, I can write a square equals 2b square, right? There is no any doubt we can write in this. So in the same expressions, we able to tell a square is divisible by 2, right? From this expressions, how we can write this b square equals to a square by 2. So this will come here, right? So so a square is divisible by 2. We can tell this, and let me find out if a can divisible by 2 or not. Yeah, of course, a is also divisible by 2. So why? Because here a square must be a into a, right? So if a equals 2 into 2, it must be divided by 2. So a is also divisible by 2. Okay, I hope you understand very well. Once a is divisible by 2, I hope A must be some, we can assume A equals to some some value, because A can be some multiple of 2. Okay, so for example, I take C for multiple. If I, for example, if C is equals to 1, A equals to 2. If C equals 2, let's assume 2. 2 into 2, 4, A equals to 4. And if C equals to 3, A equal to 6. So A must be multiple of 2. Once A is divisible by 2, here A must be multiple of 2, right? So here I take A equals 2C. Since A is divisible by 2, so A can be a multiple of 2. So in the next step, I substitute the value of A in the equations. So like B square in this equation, okay? This is 1. So B square equals 2C square, right? So further I simplify 4C square by 2. Okay, I further simplified 2, 4. So 2 2s are 4. So now we get B square equals 2C square, right? I'm going to take B this other side. So B square only 2. B square by 2 equals C square. So that means B square is divisible by 2. So we get some integers, right? C square. For examples, if B square is divisible by 2, then B is divisible by 2, right? That is the rule, like we said before. Yes, like we did this with the A. So A is divisible by 2. Once A square is divisible by 2, then A must be able to divisible by 2. The same concept I apply here. If B square is divisible by 2, B must be able to divisible by 2. So here you see A and B both are divisible by 2. So it contradicts our assumption, right? So A and B both are divisible by 2. So here we already assumed A and B are co-prime. So you can see A and B are co-primes. So co-primes means, I already said, A and B must not have any common factor. So it should be in simplest form. So that's why, so it contradicts our assumption. So root 2 is not rational numbers.